Absolutely. So welcome to this session called Designing Efficient Tableau Workbooks, the on-stage version. Can I get you to just give me a bit of an indication through show of hands? How many people for whom this is their first Tableau conference? Fantastic, look at that. So how many of you have been using Tableau for, well, maybe up to a year, or maybe 6 months? 6 months or more? Okay, very cool. So the rest of you maybe less than 6 months. Well, my name is Jason. I'm a sales consultant. I'm based out of Sydney in Australia. I've been with Tableau for a little over 4 years now, and I look after some fairly sizable customers in Sydney. And this session has come about partly due to conversations that go like this. I've built this Tableau workbook. I love Tableau. And I've made this incredible workbook, but it's really slow. And clearly it's Tableau's fault, right? And I want you to come in here and I want you to make it faster. And I want you to fix Tableau. So I had a conversation like this maybe 4 or 5 weeks ago now with a client in Sydney. They'd built a beautiful dashboard. It really was a piece of work. They'd taken a model dashboard from where they found something on the internet, a dashboard that Andy Kriebel had published, and they'd extended it. They'd modified it to suit their own purposes. They'd built it out. They'd made it more sophisticated, more complex, more robust. And everything they did to it made it slower and slower and slower. And it got to the point where it was taking 40 seconds to load. And then every time they touched it, every time they looked at the thing, it would take another 40 seconds to re-render. And clearly that wasn't working. So they called me in and they said, you know, what's going on here? Can you make this better? So today's session, the material for this session is drawn largely from this PDF document, this beautiful piece of work by my former manager, Alan Eldridge. He wrote this document about 3 or 4 years ago, and it distilled a whole lot of material that was available on the internet. And it described all of the ways in which, or the factors that affect performance, and the things that you want to keep in mind when you're designing an efficient workbook, a workbook that goes well. So this presentation is drawn mostly from this document. If you haven't read this document, it is a lengthy piece of work. It's a robust document for sure. It's quite technical. But I would urge you to go find it on our website. Bookmark the thing in your browser, because you will go back to it. You will go back to it over and over and over again. I'm going to take you through many of the concepts that are presented in this piece of work, of which there are many, and we're going to set a fairly cracking pace. So I apologize, morning after Tableau party. There's a lot to get through. So we'll be covering it in a fairly cracking pace, and unfortunately I don't think there'll be a lot of time for Q&A at the end. In fact, we'll be lucky if we get to it in 60 minutes. But there are 3 things that I want you to take away from this session, if nothing else. And one is that the choices that you make when you set about building a visualization have a direct impact on the performance characteristics of that workbook. And so it is the case that you often cannot adopt a design model or a way of thinking and go down that path and just think, well, we'll fix performance later. We'll build it out according to what the boss wants, and then we'll fix performance later, because largely you can't. And so performance is definitely not an afterthought. You've got to design with performance in mind. And because there's a lot of things that we're going to go through today, there's no one factor, there's no one silver bullet that you can say, you know, this will always fix performance in my workbook, because you're going to have to look at all of these factors with respect to the various characteristics of each of your workbooks and analyze how they affect performance in respect of that particular scenario. During this presentation, I'll use expressions like avoid, or use sparingly, or minimize certain features or design characteristics. And what I don't mean is don't do it. I mean, go ahead, but in consideration of the likely impacts of those choices. You know, if you go down a particular path, you need to be aware of the possible impact of the choices that you're making. As we go through the session, have a look for the flashing red light, and these are the key points that you'll be able to take away. The session is being recorded. The material will be made available for download later on, so there's no need to get too hung up on all of the details. I said 3 things. I'm going to draw out 1 thing before I start, and that is, if your workbook is slow in desktop, It will be slow in Server. Server's purpose is not to make a workbook faster. Server's purpose is to scale it out to thousands of people. So if you've got a really slow workbooking desktop, it'll be really slow in Server. So keep that in mind as well. So what do we mean by efficient when we're talking about Tableau workbooks? Well, clearly we want the thing to be fast. We want it to load quickly. We don't want to be sitting and watching the spinner. And when we interact with that dashboard or workbook, we want it to work quickly as well. We want it to come back to us in a timely fashion. We want it to be flexible. It's all well and good to engineer a technically brilliant piece of work that answers one and only one question, because you might want to be able to service additional questions through that workbook, so you want some flexibility built into it as well. But on the other end of that scale, you don't want to just vomit all of the data in the database on a page and cover the page with quick filters in the hope that your user will be able to answer any question, because then it will perform like a dog, guaranteed. And of course, we want things to be reasonably simple. You know, if you engineer something that is really technically complicated in order to obtain a high degree of performance, then the next person that's charged with coming along and maintaining that thing may never figure out what you've done. So simplicity is also a key. We want to balance these three things together. So we've got a workbook. It's slow. So tell me, how many folks have had an experience where they've built something or they've inherited something and it's slow? Good grief. Well, I guess that sort of explains why you're here, I suppose. So why? Why is my workbook slow? Let's think about rendering a visualization using Tableau Server. At one end of the spectrum, we've got our browser. In the middle, we've got Tableau Server. And at the other end of the spectrum, we've got the data, wherever that may live. So we ask Tableau Server to render a visualization. We have to go into the repository. We get authenticated and authorized. We bounce around inside the repository for a while. We load the viz. We get it out of the repository, unpack it, and then we have to figure out what data is required to render that viz. So we send some queries off to various data sources. It might be our own data engine, or it might be external data sources. Those data sources could be a local SQL server, or it could be an Exasol instance on the other side of the world. We run some queries, and that takes time. And those queries generate data that need to then come back to Tableau, and that takes time. We then have to do something that's called compute the model. And this is everything from just drawing some bars through to something more sophisticated. Like, for example, if you're drawing a scatter plot, an XY scatter plot, and you've got a customer ID or order ID on the level of detail, then you might be rendering 5,000 marks on the scatter plot. And then you turn on labels. Well, we've got to then selectively determine which labels we can draw and which labels we want to hide in order to make it readable. So all of that goes on when we're computing the model. Having done that, we then have to package up some data and some initial JavaScript code into what we call a bootstrap, and we send that back to the client, the browser, so that the browser can then compute what's going on there and render the viz. Or if we're using server-side rendering, we would render the viz using image tiles, and then we'd have to pack those image tiles up and ship those across to the browser so that we can then render the viz. And you thought Tableau was just a drawing tool, right? There's a lot going on. Clearly there is a lot going on from the moment you say view worksheet to the point where it comes up on the screen. So knowing all of that, and this is a very simplified version, where do you think there might be scope for there to be inefficiencies or slow performance? Call it out. In the queries, yeah, 95% of all audiences say the queries. It could be moving data backwards and forwards. So I'll give you a hint. All of it. Everything except when I click show me the viz. Well, that's kind of depressing, isn't it? Well, in order to work our way through that, let me propose a bit of a model that might simplify our thinking. And if we think about what's going on from the point where we render a viz or request to render a viz and then we see the thing, let's think about this in terms of a stack where we start with the platform layer, then the analytics layer where we compute stuff, we calculate numbers, the data layer itself, and then the platform layer. And I've chosen to use this inverted triangle representation because in a way it gives me an indication of the increasing degree of frequency with which issues might occur. So from the platform layer up to the presentation layer, the places where things can go wrong increases. But happily, it also gives me an idea of the degree to which we can affect change. So it's a lot easier for me to change the way that I'm building my visualization than it is for me to go grab another 8 cores of computing hardware and 64 gigabytes of RAM and stick it into my cluster. So I'm going to spend perhaps more time at the top of this stack, and then as we drill into it, we might accelerate, because you have less control over that as the author or a consumer of a visualization. But before we go there, we have to figure out what are the tools that are available to us that might help me locate where the problem could exist. How many people know about and use the performance recorder? That's not bad. That's maybe 35%. That's pretty good. The rest of you, you need to know this. This is perhaps the first and the easiest place to start looking for where you could find a potential bottleneck. And when you're using Tableau Desktop, you go to the Help menu, scroll down to Settings and Performance, and it's kind of hidden away. My colleague, Mac Breiler, is a large champion for having this as a big, prominent button on the dashboard menu, but it's hidden away here: Help, Settings and Performance, and Start Performance Recording. Best practice is to start with an empty Tableau worksheet. Start your performance recorder and then load your workbook. So we start capturing everything that happens as the workbook is loaded into memory. Once your workbook is loaded, play around with it, work around inside it, make some selections using quick filters, trigger some action menus and things like that, and then say Help, Settings and Performance, Stop Performance Recording. And what happens then is Tableau will push to you a new workbook that opens in another copy of Desktop, and it looks like this. It's a 3-part viz. On the top, there's something of a timeline or a Gantt chart representation that shows you all of the various actions that are occurring within each of the dashboards and the worksheets that exist within that workbook. Underneath that, in the middle, there is a representation of all of the events sorted by time taken. So this gives you an idea of all of the stuff that's going on as you're working with your workbook, the various types of events: rendering the view, computing the view, querying data, sorting the data, etc., etc. And then underneath that again, you can select any one of those those bars. They're color encoded, so select a green bar there, executing query, and you can see the actual query that is being sent back to the data source. So you might be able to then go and have a conversation with whoever runs the data source to say, well, is there some way we can make this faster at the data end? Or let me go back here a second. Perhaps we're seeing that the query is not the issue, but there's a lot of work being done in computing the layout, which would indicate that the physical layout of your dashboard is maybe too complicated. There's too much going on. The story that I was telling you earlier on with that client with that complex data dashboard, there were 43,000 lines of XML code that made up their workbook. Now, is that good? Is that bad? I don't know. But it caused Tableau to be spending a lot of time parsing the XML. It was just really complex. Now, the performance recorder is also available from Server. As a site admin, you'd need to turn this feature on, and then as a consumer of a visualization, you would put a suffix on the end of each view that you wanted to look at, and then you can download the performance dashboard and open it up in a new workbook. So those are the two easiest things to do. And then the logs themselves, the desktop logs. If you're not afraid of getting into something like logs, these are located in the My Tableau repository logs folder, and you can just grab them. You could open them up in any notebook editor or something like that, or you can just throw them into Tableau Desktop because they are just JSON files. Throw the logs into the two that you're interested in, log.txt and tabprotoserve.txt. You can just dump those into Tableau Server. Once you understand the schema a little bit, you can then start building your own queries to understand what's going on and understand how much time is being spent in every step of the way. Or you could grab the Tableau Log Viewer off of Git, open source piece of code. You can dump the log files into that, and it's a great, very convenient way of searching for patterns, particular queries, error messages, warnings, messages, and so forth. You can also grab the log files off of Tableau Server. A site admin or a server admin can do this for you. You can just use the Tableau Server UI to generate a snapshot of the log files off of Server. And then you might be able to dump those log files into Logshark, and Logshark will parse them for you. There's a number of plugins available that can analyze all of the various things that are going on within Tableau Server, and you could maybe focus on what's going on with these workbooks. Here, the focus turns away from one specific workbook, and we can start to see what's going on with lots of workbooks. We can see that maybe there's a pattern on a Monday morning where everyone's workbook starts slowing down, but through other parts of the week, they're okay. Baked into the Tableau Server UI itself are some server performance views. These are mostly targeted towards the admins, but there's a couple here that are really relevant for people who are looking at workbook performance. So there's load times for individual workbooks, and then there's load times for all workbooks across the server. And this might look like this. So here's a screenshot of the overall load times for views, and you can see that most of these views are loading in the light blue color in less than 3 seconds, but there are some workbooks that are starting to take between 3 and 10 seconds, and that's a little bit uncomfortable. If you want to get your geek on a little bit from your browser, all of these browsers have a console, a development console of some sort. You can press F12 and then maybe target the network traffic, and you can actually look at all of the network traffic that's happening between the browser and Tableau server. And you might see, for example, this little long green bar that's at the bottom here. That would be that bootstrap that I was talking about before, where we're packaging up the data and the JavaScript code for the initial rendering of the view. And if we see that that's taking 8 to 10 seconds to transfer, maybe the problem is the network transfer, not necessarily the view itself. And if you really want to geek out, you can grab a hold of a tool like Fiddler or Wireshark and get right down to the packet level. These are obviously very good for diagnosing things like authentication errors and so forth. And lastly, Tabmon, another tool that's open source. It's available on Git that, again, allows me to get a view of everything that's going on in Tableau server. And once more, we could start to see maybe what's happening. Maybe we're suffering low cache hit ratios, or maybe we've got an extended disk queue length, which is causing everyone's workbooks to slow down. Right? So we could go from the desktop all the way down to the server in trying to understand where the problem exists. So let's jump in and spend a bit of time in the presentation layer. This is where we're talking about dashboards. And our dashboards are made up of worksheets and other areas, other zones. All of those zones are all of the things that are in that red box there. You can throw zones into various layout containers. Who's played with layout containers? Excellent, excellent. So we can have non-data-driven zones, things like text boxes, blank space boxes, images, web content, as of 2018.3, buttons, extension objects, right? So all of those things, but they are not necessarily data-driven. But then there are data-driven zones, the worksheets themselves, the filters, the parameters, page controls, color legends, and so forth, all of which have to obtain data from somewhere, and they're populated by data. So the more of such elements you have on a page, the more data needs to come into Tableau to render that page. So our worksheets themselves, clearly, these are the main data-driven zone, and they're made up of panes and headers and axes, legends, marks, and so forth. And it's the marks that we are principally concerned with. In this example here, every one of those bars is made up of segments, and every one of the segments in those bars is a mark, and each one of those marks is getting data from somewhere. It's an aggregated piece of data. So pro tip number 1, keep your worksheets as simple as possible. And I know this is where the tension starts, because there is a real desire, at least in people who are starting their Tableau journey, to throw as much as possible onto a worksheet. And so one of the things that we see very often is people building large crosstabs into their worksheets. Now, a crosstab is not a visual analytic metaphor. It's a way of listing things. Now, in Tableau, we don't necessarily want to list everything that's in our database. We want to analyze. So there's really no place for extremely large crosstabs of 50, 60 columns and 10,000 rows in a visualization. There is a place for small crosstabs when you want to drill down and actually then see a little bit of detail where it's relevant, but there's no place for huge crosstabs with segmented views, scroll bars on the bottom and the side of the page. If you have those things, you're not using Tableau for the sort of things that it's designed to do. So if you've got 50 columns along your page and 10,000 rows, you're not seeing most of that data, and you're probably not using most of that data. So the answer there is to don't bring it in. Don't bring in data that you're not going to use. Don't render data that you can't see on the page. So keep things simple. The idea here, the driving philosophy here, is to keep the number of marks on the page to a minimum. It's not always easy to see where the number of marks is, but if you go down to the bottom left-hand end of the page, you'll see the number of marks, the number of rows, and the number of columns of data that have been brought into Tableau. The thing to remember about marks is that they're not all the same in terms of their rendering characteristics. The native mark types like bars, circles or shapes and lines and areas, these do render very fast. Tableau's optimized to do that. But we can manufacture various polygons. Maybe we've built our own custom geographic territories. But to render custom polygons, we need to draw a line around a set of vertices. And we'll know that a curved arc is really just a lot of points. So if we're doing something like this very spectacular viz here that's made up of all of these curved segments, every one of the curved lines in those segments is made by creating a XY coordinate system. And so we're probably using an interpolation trick or a densification trick where we might be interpolating the data points along the x-axis, or we might be using a densification scaffold, and then we can plot the Y series along maybe a sigmoid chart or something like that. So these types of manufactured curves cause Tableau to be doing more work, and they take longer to render. Similarly with maps, a map is not always the best answer to a question involving geospatial data. If the question is simply to determine which zip code or area code or postcode has the highest value for any metric, drawing all of those as polygons or maybe circles and then looking for the biggest circle or the deepest colored polygon is probably not the most effective way of answering that question. You might as well just draw a bar chart, sort it by descending order, and then take the number off the top of the list. Now, when we're building dashboards, of course, we want them to be interactive. We want to be able to use filters or parameters. We want to be able to select marks off of a visualization, trigger dashboard actions, URL actions, highlight actions, and filter actions. But be aware that everything we do causes additional work to happen. And that work comes at a cost. When we're building a dashboard, we need to be aware of the number of zones that are on the dashboard or on the sheet and try to minimize the number of zones. Now, this dashboard is an Andy Kriebel work of art. And this was a beautifully crafted dashboard that was a nice way of visualizing a year-to-date income statement. I'm not here to criticize Andy's work because it is beautiful, but we might have an issue with this because of the number of zones that are on the page. Each one of these little metrics here, gross sales, discounts, net sales, and so forth, is represented by a tuple that is comprised of a bullet chart and a sparkline. So each metric has 2 worksheets associated with it. And there are 9 metrics on the page there. So there's 18 zones on that page. And of course, we've got 3 quick filters across the top there. So each one of those zones is doing work. So we need to be aware of that when we're designing our dashboard or our worksheet. Closely followed onto that is the question of filters. Now, I know when we're beginning our Tableau journey, we can be guilty of just blindly throwing quick filters on the page because we just want people to be able to filter anything. But particularly in the case of enumerated lists of dimensions that have a very high cardinality, customer name, order number, product name, these dimensions have a very high cardinality, and if we're putting quick filters on the page that are associated with these fields, there's a lot of data. I have a customer in Sydney who insists that they need to put a quick filter on the page for customer name, and they're a telco. You can imagine how many customer names are in that quick filter, and then they complain that it takes a long time to render the quick filter. These large enumerated lists are not effective if you're trying to use them as a filter. I would suggest that rather than use a drop-down list when you're looking at large enumerated sets of values, it's more effective to use a wildcard selector, where you enter a wildcard pattern, and then that's resolved at the database or the data source, and what comes back to the filter is only the list of values that satisfies the pattern. So you might get 100 values come back rather than 6 million. So that might be more effective. You want to avoid high-resolution images because they've got gravity, they have to find their way across to the browser, and complex embedded web pages, because they just slow everything down. Talking about filters, we need to be quite mindful of the impact of things like global filters, where we apply to all using this data source, or the impact of filters that apply to all the sheets on the dashboard, or filters that show relevant values, because these all take work. They'll cause more work to be done. Looking at this image here, we've got the 3 filters along the top, region, and I think it's category or channel, and then a product. So when we modify one of those quick filters, the others need to be modified as well. So if we select region, not all products might be sold in each region, so we have to update the filters that are associated with our selection. And then, of course, we then have to update the rest of the dashboard. So if we modify one of those filters, we'd have to send queries away to modify the other 2 filters, and then the queries that go away to satisfy all of those worksheets. So on this one dashboard, we could be potentially sending 22 queries off to the data source. Some of them may be resolved by cache, but some of them may not. Right? So there's work there. Talking of cache, one of the simplest things that we can do to help Tableau optimally use cache is to set the size of our dashboards and our stories to be fixed. As soon as we use an automatic value, then we disable the ability of using, or we can't get a hit on the model cache, because one of the attributes that determines whether we can use an entry in the model cache is the size of the device window that we're using. So if everyone's using different size devices, even if we're using the same dashboard, we could potentially be not getting any leverage from cache, because my window is 1 pixel bigger than your window, so I can't reuse your cache. So wherever possible, fix the size of your dashboards and your stories. And it says here, use client-side rendering wherever possible. I mean, that's largely automatic. The more complex your visualization is, the higher the chance that we'll flip over from client-side rendering to server-side rendering. And then we have to build those tiles and ship those tiles over. So again, complexity causes performance problems. A quick sidebar on caching. There's a lot of caching in Tableau. There's a lot of stuff that's been built into Tableau to try and leverage the results of a query that's already, or an operation that's already been done. There's a lot of stuff going on inside the browser. Within each VizQL session, we've got the session cache or the bootstrap cache. If we can't satisfy an operation from reusing a session, we can go down into the model. If we can't reuse a model, then we can go down into the abstract cache. If we can't use the abstract cache, we can go down and try and get something out of the native query cache. And then to support distributed systems, we also have an external cache, which copies all of those cache entries as well. So there's a lot going on, but there's things we can do to help Tableau reuse cache most effectively. A little sidebar too on query optimization. Again, there's a lot of work that Tableau does to try and reduce the work that it does. We have things like abstract queries, where we sort of compile all the queries in a workbook into one larger meta query, and we try and satisfy the results of various other queries through using one larger query. Think for something like, if I want to show sum of sales by country and by state in one worksheet, and in another worksheet we want to show sum of sales just by state, well, I don't have to run those 2 queries. I can satisfy one query from the results of the other query, because sum is fully additive. So there's a lot of work goes on to try and optimize the way we're using the data and the queries that are being sent away. There's also a thing called constant folding, where if we can determine that an expression evaluates to a constant, we won't re-evaluate that expression over and over again. But poor choices in dashboard design are the #1 cause of poor performance. And certainly, trying to just recreate what we've always done before is a guaranteed path to poor performance. But fortunately, dashboard design is one of the easiest things that we can change. So I'm going to show you a little demo here of something that's fairly typical. So there's a quick filter, and we click on a country, and that shows all of the values for state and province. We make a selection from state, maybe Washington State, and then we can go and click city. Notice that every time I make a selection in one of the quick filters, everything blanks out and it refreshes. Right? And then we're sort of drilling into the data here, from country to state to city, manufacturer, subcategory. Then we go and grab a quarter and we drill into the details. And the other thing that was bad about that particular experience is that we're showing a great big long list, or we're rendering a huge list, but we're not seeing it. So we're wasting energy there. When we analyze that workbook through Performance Recorder, we'd find that that runs a total of 203 queries. And if we put all of those queries together end after end, it takes a total of nearly 20 seconds. So that's not a very efficient experience, nor is it a very pleasurable experience for our end users. By contrast, look at this experience, which is something that we refer to as guided analysis, where we're using a visualization and dashboard actions to perform our selecting. Rather than using filters, we use vizzes themselves, worksheets, as filters. So we go from country to state down to city, we select manufacturer, we grab a product subcategory, and then we can use a dashboard action to drill into the detail and open up on a new page. Then we can select a time period and we drill down to the data that we want. So that's an altogether more pleasing visual experience, and we're not trying to draw this huge list at the bottom of the page every time we do anything. So there's less work being done there. In fact, there's only 28 queries, and it runs for about 3.6 seconds total duration of processing time. So that's a better experience. I have a demonstration that I like to show people. It's on a database of over 3.5 billion rows, and I use this guided analysis technique to drill into the detail without actually showing anything on the bottom of the page until I get to my last selection. And it all runs very, very quickly. So let's jump into the analytics layer now, where we're concerned chiefly with the data elements that make up our dimensions and our measures, working with filters, building calculations, and working across data sources. We should all be aware that when we're building our data model, we can change the data type that's associated with a column in a data source. And this is particularly relevant when we're using CSV files or Excel data sources, but we can also change the data types associated with any of the data sources that we're working with. An example might be, you might have a date field that is stored as a character string, but we want Tableau to use it as a date, so we can drill from year to quarter to month to week to day, etc. So you can recast the data type that's associated with that field, but be aware that when we're doing that, we're causing a convert or a cast statement to be sent back to the data source every time we manipulate that field. And that's, again, causing work to be done. If possible, you can get the data source, the field in that data source, to be stored in the most appropriate data type that matches your analytical needs. A little notice on filters here. You may or may not know that we have this idea of an order of operations where things happen in a particular sequence. This diagram is in the online help, so you don't need to panic and try and capture it. It's explained in the online help. But filters particularly, be aware that there's a number of different types of filters. Data source filters, extract filters, dimension filters, measure filters, filters on table calcs, filters on level of detail expressions. These all occur at different parts of the query pipeline. Some of them are sent back to the data source, but some of them are resolved inside Tableau. And careless use of these could have some impact on the way things are done inside Tableau. If you've been around for a while, you might be aware or you might remember that context filters were a bit of a red flag because for quite a while they were implemented as temp tables. So you'd place a dimension filter on context and we'd run a query, extract the data, and instantiate a temp table in the database. And clearly that's an expensive operation. But then after that, queries were run on the temp table and they were pretty fast. But if you changed your context, we'd have to drop the temp table, requery, recreate the temp table, so that would actually cause a performance problem. Now happily, as of I think it was version 9, context filters are no longer implemented in that way. They're implemented almost exclusively as nested queries, so performance is not an issue so much. So if you're new to Tableau, forget everything I just said. If you're old like me and you used to be worried about context tables, don't worry, be happy, embrace the context. It's a beautiful thing, and you're going to need it if you're messing around with that order of operations to change the sequence in which filters are evaluated. Talking about filters, be aware that there are different types of filters. There are range filters, there are discrete filters, there are enumerated filters and non-enumerated filters. There's filters on dates, there's filters on all sorts of other things. There are slicing filters. We can use sets as filters. We can use filters across data sources. We have to think about the most appropriate type of filter that we want to use for our scenario. Let me show you a little example. Here's a map showing my home country, and there's a lot of data points. Doesn't matter what they are, there's just a lot of data points. And for the purposes of my analysis, I want to grab all of the data points that are in Western Australia. That's that big empty state on the west there. All of those brown points. Now, one way I could create a filter to do this is just to get my mouse and lasso all of the points in Western Australia and say, keep only. And that will generate an enumerated list of filter values, and that's going to cause a where in, great big long list of values. In this case, there's about 5,900 values. So think about the impact of that statement being evaluated on the database. Another example, or another way of getting the same result, might be to use a range filter on a convenient field like longitude. So I could simply say where longitude is greater than or equal to this value and less than or equal to that value. So we're only sending two values back in the query, and it's probably a more efficient query to run. But I wouldn't say that that's a particularly easy query for me to think of as I'm building my visualization. So maybe it's easier to just use a slicing filter and just say where state equals Western Australia. And that sends one filter expression, where state equals Western Australia, and that'll be a much more optimal query to run on the database. Who uses show relevant values? Do you use it a lot? Stop it. Don't do it. No. Again, I say don't do it, but just use it sparingly. Use it in the knowledge that things happen. So the way only relevant values has been used, implemented in the past is every time you update one of these sort of chained filters, all of the others have to be updated. And some of the queries that we've sent back to the database have not been terribly optimal, particularly when we're using a snowflake query or a star schema. You would typically have to traverse the fact table because the dimensions might exist on tables on either side of the fact table. So if we're updating location and we're updating product, we would typically traverse the fact table. So that can reduce the effectiveness of join culling, where we can drop joins that we don't need, and it can cause less than optimal queries to be sent back to the database. Good news is there's a really clever technique if you're using only relevant values where you can create smaller purpose-built data sources that are just the lists of domains for the dimensions that you're interested in and how they relate to each other. And you can put a query on that data source on your viz and say, apply this filter to all data sources that use this dimension. So it's the using related data sources technique. And in January of this year, we introduced the all values in hierarchy filter, which is a far more optimal version of only relevant values. It doesn't have the same performance issues as only relevant values does. And if you build a hierarchy out of dimensional values and then place any of those dimensional values on the viz as filters, then by default, you'll see that they're set to all values in hierarchy. So that's a nice little improvement. How many people use row-level security? Come on, there's more of you than that. Okay, security is important, right? But be aware that as soon as we say, from the server menu in desktop, create user filter, or if we're using a filter that's built using isMemberOf or username, then as soon as we're doing that and we're using that as a filter, then we lose the ability to share cache. Just by virtue of the design of the thing, we cannot share cache if we're using row-level security. So we then have to reach through to the data source. It can have a dramatic effect on your ability to scale. So you need to factor that in when you're doing your design and your scalability planning. A quick word on filtering as opposed to zooming. Obviously, filtering reduces the data that comes into the visualization. But if we zoom in on a map, let's say we've built a map with 1 million data points and we zoom in to New Orleans, we still have the 1 million points on the map, but most of them will be outside the view portal. So it doesn't reduce or improve the efficiency of that. We're just changing the view portal. We're not changing the amount of data that's in the view. So when we're building calculated fields, be aware that there's different types of calculations. There are calculations that are done at the row level, and there are calculations that are done at aggregate level. There are calculations that are done on level of detail, and there are calculations that are done as table calculations. Most of these are sent back to the data source. Table calculations are done inside Tableau. And that affects things like building external services or calls to external services such as R and Python and MATLAB. When we're building calls to those services, they are created as table calcs. And as table calcs, you have to remember to set your partitioning and your addressing, compute using. Tableau will make a call to that external service for every value that's partitioned. So if you partition your viz by customer name, and you're making a call to Python or R, then we're going to make a call for every customer name. And that could take a lot of time because we're serializing all those calls and sending them out they're being evaluated and the data is being brought back in. So think carefully about how you are setting your compute using. Some simple laws of physics. Operations on strings are much slower than operations on numbers and dates, and they're slower than Booleans. Well, okay, so I've got that round the wrong way. Numbers are faster than dates and Booleans, and they're faster than strings. So avoid extensive operations on strings. Compare, contains, find, in, length, right, all that sort of stuff, because they can be terribly expensive operations, particularly if there's no indexes on those columns. Aggregate functions like count distinct can be quite expensive, depending upon the database that we're talking to. Who uses attr, the attribute function? Probably you do and you don't realize it. I see a lot of people with attr sprinkled liberally all over their visualization. Not many people realize that an attr is really an if statement. So if the min of my field is equal to the max of my field within that partition, then I show the value of the field. Otherwise, I show an asterisk. So every time I use attr, I'm doing a logical expression. So if you know that the domain of values doesn't change within that partition, don't use attr, just use min or max. You'll get the same answer, and it'll be half as fast. Level of detail calcs, they're done in the database, they're done as nested queries. They can be relatively expensive if you've got massive amounts of data. You can think about maybe replacing an LOD with a table calc, because rather than doing LODs over 10 trillion rows of data, you might be better off doing a table calc inside Tableau over a few hundred rows. So, there are some blogs on the web about how certain LODs can be expressed as table calcs, and vice versa. When we're using logical expressions, now here's an example where you might have a parameter on a viz, and the parameter says you can show either the sales amount or the discount quantity or the sales quantity on one sheet. This is a very common technique, but be aware that when we're evaluating this logical expression, we must evaluate each of the aggregate functions before we can make a decision. We evaluate all of these. So this simple equation here, when A, B, or C, it sends this query back to the database. And notice that we've only asked for the sum of sales amount and the average of discount quantity and the minimum of sales quantity, but in fact, we're returning 4 expressions. The sum of sales amount, the min of sales quantity, but we're also getting the count and the sum of discount quantity. That's that sort of that abstract query thing going on there, where we try and send a query to the data source that will allow us to reuse data as frequently as possible. So we could reuse the count of a discount quantity and the sum of discount quantity somewhere else in this viz, and we can always calculate the average. Now I bring this up because you might have something that looks like this, where there's, I think, 30-something expressions there to be evaluated. So this example, the first time the viz is rendered and we have to evaluate each of those 30 expressions, it could take 5 minutes to load the viz, but then after that everything works very nicely. But that first hit could be terrible. When you're considering how to do things like grouping functions and building bins and so forth, aggregating dimensional values, consider using the native functions over your own handwritten calculations, because they're highly optimized to operate within Tableau. Groups, and sets, and bins, combined fields, custom date fields, you can use all of these native features inside Tableau. They're often far more optimal, better performant than building your own logical conditional statements. When you're building calculations, you do need to be mindful of the efficiency of the expressions you're building. We just spoke about using case or groups rather than multiple equality comparison if statements. They can be more efficient. A case can be more efficient than if. Be aware of the difference between else if versus else if. One is faster than the other. Regex for strings, extremely efficient and much more performant than just using string calculations. And be aware of these things called, or the phenomena of calculation explosion, where the same expression is reused over and over and over again in a recursive fashion. This can cause some dramatic inefficiencies. To illustrate this, here's a little example. The data set behind this was only 1,000 rows of text, a CSV file of 1,000 rows of Minecraft data. And the target, the evaluation was to look at the proportion of rows, of entries in that data that had a nicely formed or just a friendly domain name versus an IP address. So however many, 5% nice domain names versus 95% IP addresses. In order to calculate an IP address, we've got to parse the text in that expression. So you might start with a function or a calculated field that is address is valid IP, and it's valid if it's got 4 segments and a port number optionally. Then we go in and we call a calculated field called express remove protocol and port. And that's called 5 or 6 or 7 times in this expression for segment 5, and then for segment 4, and then for segment 3. It's called over and over again so many times. Already we're looking at hundreds of iterative calls to that calculated field, and that calculated field, address remove protocol and port, uses additional calculated fields, address remove protocol, and then we look at address remove protocol, and it calls more functions and more functions and more functions. So this becomes extremely inefficient. We could replace that with a regex. So we parse the expression using regex. That expression calls another calculated field, which in turn uses regex, and that expression uses regex, and that expression uses regex, and so on, and so on, and so on. So it's a much simpler expression to even maintain, but look at the calculation performance characteristics difference. On the top, there's the regex performance, and on the bottom, there's the string manipulation performance. One is less than a second, the other is nearly 20 seconds. A big difference. And that was only over 1,000 rows of data. You might think that performance is intrinsically linked to the volume of data that you're using. Not necessarily. Blending. We all use blending? Sure we do. We love blending. Blending is a wonderful tactical response to an analytical problem where data exists in 2 different systems. But remember that aggregating is designed to work, blending is designed to work at an aggregate level. We run a query on one data source, we bring back the data at an aggregate level. We run a query on another data source, we bring the data back at an aggregate level, and we mesh them together at an aggregate value. Blending is not designed to work at the row level. One of the first examples I saw of this, a customer was pretty unhappy that his workbook was taking 10 minutes to load. He was blending at customer level, and he had 20 million customers. So that's causing 20 million customers to come into Tableau and try and use blending inside. So we're trying to use the desktop as an RDBMS, and that doesn't work. So don't blend on high cardinality dimensions. If you have to do that, consider a cross-data source join or building a view on the data in a database. We've got these things called primary aliases and primary groups that we can use when blending. If all we're looking for is a label, an attribute that we're getting from a secondary data source, we can get those attributes and push them into the primary data source and then remove the blend. Right? So you can do some Googling on primary groups and aliases when we're blending. So let's jump into the data layer. And here we're concerned, obviously, with our connection to the database, the data model itself, and maybe thinking about using extracts. The first thing to be aware of, and I guess this is a little bit esoteric if you're a non-technical user, is that various connections to different types of data sources have different performance characteristics. Right? Our native connector to Oracle or SQL Server will behave faster than an ODBC connection to the same. So make sure you've got the latest version of the drivers installed on your desktop machine and on server machine, and just be cognizant of the performance characteristics of the connector that you're using. Be aware that embedding an extract in a visualization when we publish it, we tend to think, and particularly as a server admin, we'd like people to reuse data sources when we're publishing our vises, but it is a fact of life that an embedded data source can be faster than a published data source. It's because when we're embedding the data source, we can create these things called acceleration views, where we know how, things like show relevant values filters, we know how they're used, so we can build these accelerator views inside the dashboard behind the scenes, because we know what's going to happen. But if we're publishing a data source to be used by other visualizations, we don't know how they might be used, and so we can't use these acceleration views. If you're using the query bridge for Tableau Online, and you've got online data sources and on-premises data sources, just be mindful of the number of hops that your data has to make. You know, are you pushing enormous extracts from an on-prem data source up to Tableau Online using Query Bridge? That can affect the performance of the entire system. We have this sense of data having mass and data gravity and inertia. You know, the more data you move around, the worse performance becomes. That's just a fact of life. So having all of your data in one place can be really good. You know we can do great things with unioning and joining and blending and moving data around inside Tableau, cross data source joins. But every time we're moving data from one spot to another, we're causing work to be done, and it could slow things down. Blending, I often say to people, if you're finding that you're blending in an operationalized dashboard, and you've published this dashboard, and it's being used by 1,000 people every week, that would be, to me, a good signal that you want to move that blend into the data warehouse, right? So it can work faster that way. I want to trust Tableau to do its job. I've had people say to me, these BI tools, they can't build as optimal a piece of SQL code as I can. And so I want to use my own SQL. We've got these things called custom SQL. How many of you use custom SQL? Oh, look at the hands. Gosh, okay. Many analysts have their own library of custom SQL that they've built up, and they know it works, and they've got faith in it. But have faith in Tableau as well. If you're using custom SQL, and you're using live connections to custom SQL, understand that every time you're using you're manipulating your visualization, we're rerunning that entire custom SQL from top to bottom and then picking data out of it. And that can have an impact on performance. One of the easiest things you can do, and so it's best practice, is to create an extract off of your custom SQL, and then it will behave perhaps much faster. Here's a little example. There's a custom SQL data source. We unpack that sucker and see what's behind it. And there's a number of unions and some conditional logic going on in there. So we're sort of shaping a data source using a custom SQL query. Now, the time taken to run that SQL query was about 5 minutes. So that means every time you manipulate your viz, you're going to wait that long for that custom SQL to be rerun. Now, maybe we could satisfy it using cache, maybe not. But if we look into that and we understand what's going on in that custom SQL, we take the time to understand where the data is coming from, we could potentially rebuild that as a native data model within Tableau, attached to the underlying tables. Maybe they're views, it doesn't matter. Persisted views with dimension indexes. And then we could embed the complex logic in a couple of conditional calculated fields. So we could take that scenario where that custom SQL was taking 5 minutes to run, and maybe we could increase that to something like 10 seconds, which would be a better result, yeah? So you can take the time to understand what's going on in custom SQL and potentially achieve great performance benefits. Related to this is the idea, we can do all of these great things when we're preparing data for analysis. We can do unioning and pivoting, we can do split calculations and all sorts of other data prep, and that's great because, again, it's a tactical response to an issue where we want to analyze something quickly. But all that work consumes process time, cycles of work. So the better your data can be shaped for the analysis you need, the faster it will be in Tableau. And this is a good case for building views off of the data source to satisfy your analytical requirements. You got to tuna your database. I know. It's an after-party joke. Some really important things that you can do at the database back end. Every quick filter that you place on a visualization causes an operation to be done on that column in the database. And if there are no indexes on those database columns, you're going to do table scans, which is expensive and inefficient. So you could have a chat with the data source owner and say, we're going to be filtering on all of these columns. Let's make sure we've got an adequate coverage in our index strategy. Your DBA might complain, but that's okay. Defining columns as null wherever possible so that we don't have to issue null-safe joins because they're a much more expensive operation to be executed on the database. Making sure that referential integrity is in place so that we can implement join culling and drop the joins that we don't need. Right? These are operations that are right at the back end, not necessarily when you're building your view, but these can be really important, and they're good to plan for when you're setting up your data sources. If there's no hard referential integrity in place, then we can tell Tableau, just assume RI so that we can do join culling. Good practice to use data governance in Tableau Server. Have the data experts build your connections, make sure they're highly tuned and highly performant, and then the people who are understanding the data and have the questions to ask, you can share those published data sources and build efficient workbooks on top of them. One way of achieving really good performance is to use this multi-tiered data strategy. So taking advantage of the fact that within one dashboard, we can have multiple connections to multiple data sources, right? So one dashboard can have umpteen data source connections if you really want. And you can have, at the very highest level, you can have an analysis that connects to a very highly aggregated extract, and then using filter actions, we can then go to another worksheet that filters data from another extract that is perhaps aggregated at a lower level slightly, or maybe at your data warehouse. And then when you get to the bottom most detail area of your viz, you can then go and issue a highly selective query to your raw data. So there's been other sessions on this hot, warm, cold strategy, and I would urge you to try and review them if you can. But having said that, extracts are a great way of making things run faster in Tableau. We've had the extract engine since, I think, version 6. We've just introduced Hyper last year. Hyper gets better and better and better, but don't just blindly create extracts off of your entire data set. Think about the data that you need inside your visualization and hide unused fields. That's the first thing you should do before you create an extract. And particularly when you're publishing a dashboard, hide the fields that are not used so that those fields don't come into the extract. If you're not using them for the analysis, don't use the space in the extract. Aggregate to the appropriate level. If your viz only goes down to day, then aggregate the records up to day level. And be aware of the performance impact of materializing your calculations that are in the extract. And it's a bit like the old computations versus values in Excel. Rather than re-evaluating the expression every time you're using a row out of an extract, if you materialize your calculations, you use the value, not the computation. And of course, Hyper just keeps getting better and better and better. You heard in Devs on Stage yesterday that we're introducing multi-table extracts or normalized structures inside extracts. To me, this is really exciting. This will also solve a number of problems associated with user-level filtering on extracts. So let's dive into the platform layer as we've just got a couple of minutes left. So here we're concerned with the environment itself. It's a really good idea to have someone in your environment monitoring what's going on using Tabmon. Here's an example of a view out of Tabmon where clearly something's going on here. That large slice of data that's at the bottom of the screen, that's a VizQL server that was, for whatever reason, was just stuck, but the cluster controller didn't kill it off. It was just consuming memory, not going anywhere, not freeing up memory, not doing anything useful. So maybe we have to kill that VizQL server and free up that process time. Be prepared to test both where your viz is to be consumed, right, remotely from the server, but also install desktop on the machine where the server is. So that way you can identify whether there are performance differences in the visualization on the server and remotely from the server. So maybe it's the network that's causing the problem, or maybe there are issues with latency between various points in the network topology between you and the server. And again, I reiterate that if a view is slow on desktop, it will be slow on server. Upgrade, always upgrade. We have this quarterly release cadence. I know most customers can't keep up with that, but it's a good idea to be, at most, N-1 releases behind. The more you upgrade, the more you're taking advantage of great new performance features that are provided by Tableau, the better hardware, better software, better environment, and so on. If you've been around for as long as I have, you'll know the reference here. You've got to keep them separated. So in a multi-node cluster, it's a great idea to dedicate one node to backgrounder tasks, because backgrounder can be really resource aggressive. It can be consuming all of the resources on that node and a cause of resource contention to VizQL processes. So your users will be sitting there watching the spinner while the backgrounder is quite happily processing refresh tasks. So if you can take that workload and put it on a dedicated node, the whole world gets better as a result. And finally, a note on virtualization. We all use virtualization at some point. You will have a discussion with your infrastructure folks and they will disagree with you, but it is best practice to dedicate to the greatest extent possible the hardware resources on the underlying platform to the VM that is servicing Tableau Server. Tableau Server is incredibly latency sensitive. There's a whole lot of stuff going on inside Tableau Server. All those processes, they're all talking to each other, they're all writing to disk, they're all asking questions of each other. And if Tableau Server is waiting for another host to free up RAM or CPU time, then all sorts of funky stuff can happen. And it will just basically be an unpleasant experience for everyone. So the greatest amount of dedication you can achieve, the better the performance will be for server. So there's a lot going on here, right? Our design choices impact the efficiency or the performance of our workbooks. And we need to start with performance as being our end in mind. It's not always just a question of how much data we're processing. It could be a problem with a very small amount of data, but just really, really complex calculations. You know, the whole adage of less is more. Keep your workbooks as simple as possible. This is a great way of making sure that things will be better. And there's no one-size visualization for everyone. There's no one answer to all performance problems. So let me know if you think you've identified one or two things in here that you might be able to take away and maybe start investigating against your particular problems. That's good. There's a few hands. I'm really glad about that. Thanks so much. I hope you feel now that you've got a bit of a guideway, a bit of a map that'll help guide you through the troubleshooting or the identification of some of the causes of problems in your vizzes. In terms of a few related vizzes, there was best practices for dashboard performance. This was presented by Logshark Babar yesterday. If you didn't see it, it will be recorded. I would urge you to review that. And there's another session on a practical guide to guided analytics that's later on today. Please, I can't impress upon you the need to do this enough. Do your survey. This helps us determine which sessions are being appreciated and which sessions maybe are not being appreciated, and how well we're doing. Be honest, be brutal, but be loving. And last of all, thank you so much.